Let's take a look at this system of equations. If we wanted to solve this system using substitution, it would work, but my goodness, there's no option to solve for a variable that won't give us fractions or decimals. That's not necessarily bad, but it does make the problem harder to work with. Let's instead try this new approach called elimination, where we're going to literally eliminate one of the variables, giving us a simpler equation to work with. Here's the big idea. Even though there are variables in here, everything is just numbers, and numbers can be multiplied and added and subtracted. So let's try this trick. I'm going to take this top equation. It's all just numbers, and as long as I do the same thing to both sides of the equal sign, I can really do whatever I want and keep things balanced. So I'm going to choose to multiply both sides of this equation by -2, and there's a reason for that. Let's look at what happens. If I take the -2 and distribute it through these parentheses, -2 times 4x, that's -8x. -2 times 10y, well, that's -20y, equals -2 times 16, that's -32. Just for now, I'm going to leave this bottom equation all alone, not change a thing. So leave it at 7x plus 20y equals 23. The reason I chose to multiply the top equation by -2 is so that this would happen. Take a look right here at my y's. I have a -20y and a +20y, a set of opposites. We're now going to take advantage of the fact, again, that this equation is just numbers. Even though it looks like some variables are there, they represent numbers, and numbers can be added. Let's take these two equations and add them up. -8x's plus 7x's. Well, that's -1x's. -20y plus 20y is 0 y's. No y's. The y's have been eliminated. They're not in this new sum that we got from adding these two equations together. -32 plus 23, well, that is just -9. And now I have a much simpler equation to solve and work with. We can now figure out what x is just by dividing by this -1, leaving us with positive regular x equals +9. That means we're halfway done. Our system has two variables, an x and a y. We've got the x. To get the y, well, my goodness, just take this number 9, and you can go back to either of the equations we started with, put this in for the x, solve for the y that remains. So let's do that. I'm going to take the bottom equation. You could use the top just as well. Put the 9 in for the x. The y I don't know, so we'll leave it as a y for right now. And now let's see what we got. Simplify first. 7 times 9 is 63. Now let's isolate the y, so -63 on both sides of the equal sign. 20y, those go to 0. 23 minus 63 is -40. Divide by 20, divide by 20, and I'm left with y equals -2. And just like that, our system is solved. X is 9, y is -2. Let's check it with a graph. Type in your original equations, so 4x plus 10y equals 16. There's one of them. And now 7x plus 20y equals 23. Let's see where they cross each other. 9, -2. Look at that. 9, -2. So we know we've done things right. This process is honestly, it's one of my favorites. And in your future classes and in future science applications as well, you're going to use it quite a lot. Let's now turn this into toolkit notes. To use your elimination method, you need a set of opposites. And what I mean by opposites is, in our last example, we had a +20y and a -20y. Those are opposites. The way you get those opposites is by multiplying. And you get to choose what to eliminate. So let's take a look here at our example as we work through step number 1. I want to get either x's that have opposite coefficients or y's that have opposite coefficients. Honestly, you can always do either one. Some people like to always eliminate the same variable just to keep things consistent. In this case, I think I'd like to focus on the x's because as I look at the coefficients, it's going to be easy to get a set of opposites because 9 and 3 are related to one another through multiplication. Here's what I mean. Let's just leave the top equation alone and focus on the bottom one. If this is going to be a negative 9x on top, then for my opposite down below, I need a positive 9x on the bottom. How do you turn a negative 3 into a positive 9? You got to multiply by negative 3. That's how you do it. So leave the top equation alone. Now, I'm writing pretty small here. On your toolkit, you may not have enough space. So if you want to do this on the back of the toolkit, that's not a bad idea. Here now, negative 3 times negative 3x is positive 9x. There's my set of opposites. Negative 3 times 8y, that's minus 24y. And negative 3 times 17 is negative 51. So that's step 1, get your opposites. Step 2, add the two equations so we can solve what remains to get a number for the first variable. So take our two equations and add them up. Negative 9x plus 9x, 0 x's. X is eliminated. That's the whole point. 1y minus 24y's is negative 23y's. And 28 minus 51 is, negative 23. To solve this equation, it's a simple division. Divide by negative 23 left and right. We're going to be left with y equals positive 1. Now that you've done that, for space, I'm now going to come back over here. I realize it's a lot of work to keep track of. Take the number you have for the y, choose either of these two equations. I'm going to go with the top one this time. Put the number that we have for y in for that y, and now let's solve what's left. Negative 9x plus 1 is 28, minus 1. So 9x is 27, divide by 9. And we have x equals 3, and your system is solved, just like that. So we did the third step here. Once we found that y, the first variable, substitute into one of these two equations to solve for the second variable. Last step, check our solution. So pull up the grapher, put in always the equations you started with, the printed original equations. Negative 9x plus y equals 28. Then the second one, negative 3x plus 8y equals 17. And then let's see what we got. Now I'm noticing here, I made a mistake. This is why I want you to make sure you check your work. Can you spot the mistake? It's right here. Now the reason I knew that we were wrong is because my graph intersected at negative 3, 1. And as I'm looking at my work, right here it is. I left off that negative sign. That means this division should be by negative 9, and 27 divided by negative 9 is negative 3. That's why it's important, my friends, to check your answers, because even the most experienced of us make a small mistake from time to time. Okay, quick recap, and then we're good to go. Multiply to create a pair of opposites. Add your equations to eliminate one variable and solve for the other. Substitute in one of the starting equations to find your other variable and check your answer with a graph. Give that a highlight, and we are good to go.